We now move to truth tables. They are a handy way to figure out whether compound propositions are true or false. Let's look at a truth table for each of our 5 statement connectives. But first, let's see what a truth table looks like. A truth table is a grid that contains possible values for truth functional statements like the ones we've been looking at. It consists of rows that are arrayed horizontally and columns that run vertically. The top row is called the header row. Here's the truth table for negation. As you can see, it has 3 rows and 2 columns. The top row is the header row. The header row contains a statement P and its negation, tilde P. In the columns beneath these 2 statements, P and tilde P, we have truth values. How many different truth values can P have according to this table? Just 2. P is either true or false, either T or F. When P is true, tilde P is false, and when P is false, tilde P is true. And that leads us to the truth value for negation. A negation is true if and only if the proposition denied is false. Otherwise, a negation is false. Here's the truth table for conjunction. Notice that it has more rows, 5 when we include the header row. On the left, the header row contains our conjuncts P, Q, and on the right, the conjunction itself, P.Q. The 2 columns on the left beneath the header row give us all possible combinations of putting P and Q together in a binary logic, that is, a logic with just 2 values, namely true and false. There's the case when both P and Q are true, the case when P is true and Q is false, the case when P is false and Q is true, and the case when both P and Q are both false. If we now look at the column on the right containing the values for the conjunction P.Q, we see that P.Q is true in only one case, when both P and Q are true. Otherwise, it's false. That leads us to the truth value for conjunction. A conjunction is true if and only if its conjuncts are both true. Otherwise, a conjunction is false. We can now move to the truth table for disjunction. As you can see, the left-hand columns in the truth table are identical to conjunction. The right-hand column is different because we're dealing with a different statement connective, the wedge. If we look at the column beneath the wedge, we can abstract the truth value for disjunction. A disjunction is true if and only if at least one disjunct is true. Otherwise, a disjunction is false. The truth table for the conditional is quite interesting. Again, the left-hand columns are identical to conjunction and disjunction, but the right-hand column shows us something quite striking. A conditional is false if and only if its antecedent is true and its consequent is false, which is exactly what our truth table tells us concerning the rule for the material conditional. A conditional is false if and only if its antecedent is true and its consequent is false. Otherwise, it's true. Finally, we come to our last statement connective, the biconditional. As you can see, when the values for P and Q match, either both true or both false, the biconditional is true. And that leads to our truth value rule for the biconditional. A biconditional is true if and only if both members have the same truth value. Otherwise, a biconditional is false. That concludes this segment. Please continue to the next.